Okay, so let's get started on writing and solving systems of equations using substitution. So as I mentioned before, there's three ways to solve a system of equation. The easiest one that we went over last time was just graphing them and solving it. Literally just finding where they touch each other. The other way is known as substitution. So we're going to go over that in this lesson. So let's get started. So writing and solving systems of equations. Our goal in this one, our objective, is in this lesson you will write and solve a system of equations using substitution. Substitution is this idea of if we have variables, let's go back to that P and Q problem. And so the P was a penny, and then we had a quarter. So if we're doing this, we could substitute, let's say this was, I don't know, we're going to say it's equal to y. We can substitute this equation, since they're both equal to y, into this other y. Since they're both equal to y, we just plug it in and then solve for it. Now this is a really bad example because there's like three variables, so this isn't ideally what we would be doing. But let's say we had a situation where we had y equals 3x plus 2, and then we had another one where y equals, I don't know, 5x. Let's just say 5x. What we would do is we would take this 5x and plug it into this y here, because they're both equal to y. And remember what I said? Where in the last lesson, where this is going to have a point where the x and y are the same. So we're going to assume that this y is already the same. So let's get into that for this lesson. Let me erase this. So let's get into this. So our warm-up exercise. So Gina's math class, each student is making a logic puzzle for another student to solve. Gina decided to solve her with volleyball. So she's using singing volleyball. So right here, you guys might have seen questions like this on Facebook. What we're basically doing is this is a logic puzzle, but let's think of it this way. Let's pretend that this volleyball is an X, and the music note, we'll call it Y, and these books are Z. So we have this really weird uh, system of equations that we've seen before. It's a logic puzzle. So a lot of people don't realize that this first equation is really this. And the next equation is really this 3z plus 2x, because the volleyballs are x. And the last one is 4y equals 8. And the last one is x plus y plus z equals something. Now, the key to this, if you guys have done these logic puzzles before, is to figure out this one, the one where all of them are the same, because this is the easiest one to solve. And we're going to go over how they solve that in this question. So let's get to that. So let's go into the introduction. So this logic puzzle, they're going to be like, hey, if we add 2 a bunch of times, we can figure out that that's 8. So we're going to plug in 2 for this. We're substituting in that 2. Well, if we figure out that this is 2, then we have 2 of these. So this has to be 5, because guess what? 5 plus 5, they're the same. They cost the same because they're the same shape. It has to be 5. So now we know what this 5 is. Now we just need to figure out this book. Well, if we figure out the book, these 2 volleyballs are going to be 10, which means these have to be 3, because 10 and all of these have to be the same. They're books. Now, let's take a look. So now we're going to solve using substitution. Now we're going to get into it a little bit more. So we know this is one solution because the lines intersect. We learned that from the last time we dealt with system of equations, is they can intersect 1 time, 0 times, or infinite number of times. So let's look at this. So we're going to do a negative and a positive. So we're just slowly figuring out the slope. We're finding out the rate of change and the y-intercept. So here's the y-intercept here at 1, and our slope is -1/2. And then this one, we figure out y-intercept is -1, and we're going to go up 3/1. So rise over run. So always remember that this is our b, because it's our y-intercept. It's where we begin. I know when we're dealing with negatives, it doesn't really look like a beginning, but we're assuming that we're only doing positives. And then this rise over run is how we move. How are we moving our rise over run? So just remember, it's always the rise divided by the run. Let me get a little more purple. Run. All right. So 3 divided by 1 is just 3. And that, of course, comes from this idea of y equals mx plus b. So that's why that's there. So quick refresher on how to write a linear equation. So let's move on to the next one. And then we're going to intersect them together. Well, these are both equal to y. So what we're going to do here is we're going to make them equal to each other. So we're going to take this, let me grab a pen. We're going to take this, move it over here, and that's what allows us to move it there. And if you'll notice, this part is the same as this part. So we're literally just taking it. So having it in y-intercept form is very useful because you can just plug in the y's and then solve for x. Well, once we solve for x, so now we're going to take that. We figured out that x, so you can do the work here. They did the work for us, and they figured out that was x. We'll do more of these later. Once we figured out what x is, we can take that x that we solved from the last problem, the one we solved right here, this, and plug it into either equations. It's pick and choose. You can choose which equation you want. You can either plug into this one or you can plug it into this one. They chose to plug it into the latter. Okay, so here we are going to move on and we're going to try it ourselves now. Now we're going to try to solve this ourselves. So we have these two equations. Well, guess what? We have to figure this equation out. We're going to figure out line 1. The first thing I'm going to do is figure out what my y-intercept is. What is my b? Well, my b looks like is right here at 2. Next thing I have to do is figure out my slope, to figure out my rise over run. I don't remember what colors I used. I think it was blue and purple. I'm going to try those right now. So first things first, let me do my rise. So my rise, first you have to kind of pick another point. So I'm going to make it in purple because I'm going to end up using purple anyways. What you want to do is you want to go along this graph and try to find where they kind of goes on the grid. And by the grid, I mean this little grid right there. So now that I have that, now I figure out I have to go up 1 to get there. And then I have to go over 1, 2, 3. So my slope ends up being, my rise is 1 and my run is 3. All right, so that's probably going to be the only time I go into that much detail, but that's how you figure out your rise over run. I'm sorry, the colors didn't match. So what I'm going to do here is I'm going to get rid of this m. I'm going to replace it with a fraction, and that fraction is going to be 1/3. Now I need to plug in my intercept, and that's going to be 2. Let's solve that. Incorrect. I wonder if this thinks, give me a second, because Edmentum likes to mess with me. Nope. Oh, shoot. I just realized, guys, that I did it for line 2. Well, since I already have line 2, might as well take advantage of that. So I did the second line. I'm going to plug in the second line right now since I already have it So I'm going to do that. And it was an intersection of 2, so we'll just do it there. One thing that's kind of, I think it's interesting, is if you're multiplying 1/3 times x, you can also say it's x over 3. The reason why we do it this way, though, is it's really obvious that this is an m. This one, it's a little harder to see that it's a line. So let me go over to this. So I'm just going to calculate this out real quick. I'm not going to color code it because it's just going to take a while. So here, my b is equal to -2. And I'm going to do another point. So I'm going to choose this one. And this is up 2 over 1. So my m is 2. So that's why they wanted you to do the first line one first, is because this one doesn't have a complicated formula. You don't have a fraction. I'm just going to change this to -2 because it is technically plus b, but remember a plus and a minus make a negative. So we're going to change that. Cool, we got that going. All right, so use the answers from parts A and B and substitute method to solve the system of equations shown. So we have this, so we're going to substitute this in. So if we have one equation, and that equation was, oh, I'm going to take advantage of the fact that they give us the answer there to kind of help write these together. So one is y equals 2x minus 2. The other one is y equals 1/3 x plus 2. So I'm going to set these equal to each other. I'm going to make this the blue one. So I'm going to do 2x minus 2. I'm going to set that equal to 1/3 x plus 2. And I want to move all my x's to one side. So what I'm going to do here is I'm going to switch to more of a black color. I guess there's no real black here, so I'll just do dark blue. What I'll do here is I can do 2x minus 1/3 because I'm taking away 1/3 from both sides. And I'm going to add 2 to both sides. So this is going to end up being 4 because guess what? 2 to get rid of this negative makes it a 4. So now I'm going to pretend this is a 2 over 1. I want the denominators to be the same. Otherwise, I can't add them. So I'm going to multiply the top and the bottom by 3. So I end up getting 6x over 3 minus 1 times x is x over 3. So I end up getting 5 over 3x, or 5x, is equal to 4. Well, this is a little complicated. I'm really surprised Edmentum's making us do a complicated fraction. So now what we're going to do is we're going to have to flip this over and multiply by both sides. The reason why we do this is if we're dividing by 3 and multiplying by 3, they cancel. If we're multiplying by 5 and dividing by 5, so multiplying by 5 and dividing by 5, these cancel. So we're just left with x. And this is equal to, pretend there's a 1 under here if it helps. We get 12 over 5. So our x value should be 12 over 5. And luckily for us, there's only one answer with 12 over 5. So take advantage. Take advantage of the fact that it's multiple choice. Otherwise, Edmentum didn't think this through. They should have had another answer to make it more challenging for you. But luckily they didn't. So what we're going to do here is they plug it in. But we skipped that step because they decided to make a multiple choice problem without multiple x's being the same. So they were a little nice to us there. So I think the hardest part for you guys was multiplying by the radical. So multiplying by the radical, the reciprocal. Reciprocal. That's the idea of us flipping it. When we flipped over this, oops. Oh, that's how come it stays in place because of the scrolling thing. Huh, that's good to know. Um, this idea where we flipped over the 5 over the 3. That's probably the hardest part. So that's what I think is probably going to be the struggle for you guys. Remember, focus on what you need to understand here. What are your struggles? That's the best reason to doing those. All right, so this didn't erase. There we go. All right. So now we're going to write a system of equations. This one, I feel they're trying to challenge you, but they're honestly not that hard. Um, Especially when we already know. Remember, our B is our y-intercept. Our B is always our y-intercept. What's a y-intercept? Well, a y-intercept is when x equals 0. So check this out. This equation has b equals -3. Simple. This one does not have a b. B equals 0. And when we add 0 to anything, it stays the same. So we're only going to focus this one. This one's a direct variation. All right. So now let's see if these have constant slopes. So I'll bring that back up later. But what's happening here is we're going to figure out how far do we move. Well, we're going to move up 1. When we go from -3 to 2, we're moving up 1. And then we move up 1 again, and we're moving up 1 again. So it looks like our rise is consistent. The rise is 1. Let's look at our run. Our run, 1, 1, 1. So our rise over run is 1. So the rise and the run never change. You might have instances where you might have to take this number divided by this number because they're being nice to us here. They're only increasing by 1. Well, let's take a look here. So our rise here is 1, rise is 1, rise is 1. We keep increasing by 1. So our rise is run. Let's take a look at our run. Our run is 2. We went up by 2. And then from 0 to 2, we went up by 2. Then we went up by 2 again, and we went up by 2 again. So that means we're always going to have a rise over run of 1/2. Technically, we already know we're working with lines, so we don't really have to worry about it being consistent. But in the real world, if you have a table, you don't know if it's linear or not. You just kind of look at the patterns. So you can see here how they're calculating the slope, and they're calculating the intercept by looking at where x equals 0, where x equals 0. So that's how they're coming up with this. Our slope here was 1 because our rise over run was 1. This one, remember I said it's direct variation. You cut this in half, you get that. Cut that in half, you get that. Cut this in half, you get that. Cut this in half. Yeah. All right, so moving on. So those are equations. Go into the next slide. So solving algebraically. So when we solve algebraically, we want to basically set them equal to each other. Once we get that, we can plug in this 6, this x equals 6, into our x. It doesn't matter which equation we plug it into. We could plug it into the original equation, or we can plug it into this equation. You have a choice. There's not an exact way of solving. All right, so, and then there's also extending using tables. So extending tables is just this idea of we're going to complete the table by following the pattern. If we rise 1 and run 2, rise 1, run 2, rise 1, rise 2. And then finally, we can graph them. So we can always graph these. So I'm not sure why they want us to do this. I think what they're doing here is if we complete the table, we're finding where the x and the y are the same. I've never really heard of this method, so completing the table. That's why I'm like, wait, why are we doing this one? They just keep doing it down the line until they do it. It's a little easier to see in a graph why they do that, but let's move on to actually solving this. So if we're looking at this, when do Martha and Tara have the same thing? So I think this is when they want us to do this by completing the table. So let's see when the week match up. So the only time I see, so we can't really complete this with a graph because if you see here, Tara has more than Martha. And then all of a sudden, later on, so we haven't gotten to that point yet. Eventually, it looks like because Tara here, she keeps getting $20, right? But Martha's getting $30. So that means that at some point in time, Martha is going to get way more, or not way more, a little bit more than Tara. So let's see how Edmentum decided to solve this for us. So the system, let me clear the board. The system they have is this. Martha doesn't start off with anything, but she gets $30. So that's where our slope comes into play, our rise over run. That 30. And here's this, but she started off with $40 at the very beginning. So our intercept was that. And then if we look at our solution, if we keep extending that graph the way they do it, in week 4, they're going to have the same. So guess what? If we add 20 more, they're at 120. She's going to add another 30 more. Let me kind of show that. We're going to add another 20 again, which makes it 120. And we're going to add another 30. Well, 90 plus that is 120. So by week 4, they have the same amount of money. After that, Martha's going to make more money, but they just were wondering when they have the same amount of money. So let's rewrite equation to solve. So guess what? This is not helpful. Not at all. It doesn't help us because there's not a specific like x equals or another one where it's y equals where we can just substitute it in. So we're going to have to rewrite this. So let's see. I'm tired of like showing the work and then Edmentum's like, here's the work. So what they're going to do here is they're going to take this equation and solve for x. So what they did here was what are they doing here? Give me a second. Oh, I see. They're taking this equation and solving for x because they're like, I don't really want to deal with this negative here. So they're just going to subtract that and solve for x. I wasn't really paying attention to what was happening here. I was just looking at the box. So then if we know what x equals, why don't we take this x here, this, I keep like doing that when I know I can circle it. We can take this and plug it into this x over here. And it's just a coincidence that I happen to use blue. So let's move on to the next one. And then it's like, cool. Now we have y's. We only have y's. And then they're going to solve it so they can see it here when you guys are working on it. They solve for 2. All right. Well, we're going to take that y that we got and we're going to plug it into this. So we can choose either one that we want to solve for. Well, we already have this equation from when we rewrote it. Why don't we just plug our 2 into there? All right, so if we plug in there, our x equals 3. So the point where these two lines cross each other is at that point, the negative 3, 2. I should have drawn the arrow this way, but you guys get the idea. All right, so let me clear this out and move on to the next slide. So let's try to do this on our own. As always, I highly recommend watching the videos. I just don't want to do a video within a video. All right, so in last night's game, Matt scored 24 points. So Matt scored 24 points, and let me write it up top here because I know they're going to fill it out. You know what? Let me just go through this and just explain visually what's going on because I'm going to write all this stuff and they're going to end up writing it anyway. And so he scored it with 2 pointers, 2 more 2 pointers, and 3 pointers. So this guy scored a lot of 3 pointers because he only scored 2 more 2 pointers. So he's pretty close. So if we look at this, we have this as 2 times however many 2 pointers. So this is 2 pointers. We have to multiply by 2 to get his score. And then we're also doing 3 pointers. So he's also doing 3 pointers. So whatever number of 3 pointers he has is our y. And we know that his 2 pointers, that's why they do it in blue, was 2 more than his 3 pointers. So however many 2-pointers you have, we can figure that out by taking his 3 pointers, which is y, and adding it by 2. So that's where they got these two equations from. Now that we know what x is, we're going to take this x right here. They color coded it for us nicely. And we're going to plug it into this x right here. That's the part they didn't kind of emphasize, is we're taking this and plugging it into there. They kind of show it here, but I like kind of making it a little more obvious. Then we're going to distribute, and algebraically we're going to solve for that 4. Now that we have that 4 in the very next slide, let me erase this. You're going to take that 4 and plug it into either equations. Now, I always tell people there's not a wrong answer, but there is an easier answer. You can take this 4 if you want. You can take this 4 and stick into this equation, but that's a lot harder than taking it and plugging into this equation. Why go through all this hard work? Work smarter, not harder. Harder. So guess what? You're going to take that 4 plus 2 and you get 6. That's how you get your 6 pointers. I know a lot of people that take the word problem and it's like, oh, I just keep trying to do it. That's fine for the easy problems. But once you get into more complicated math and you don't understand how to rewrite it into symbols, it does take a while. So let's go back to this problem. We're going to try to figure this out. So guess what? What we're going to do here, we're going to make symbols. So B is going to be for books. So this is B plus B plus B. And M is our music note. So M plus M. So guess what? In the first equation, we have this 3B plus 2M equals 36. And then our next equation, I'm just going to write in blue just to make this easier on me, is B, that book, plus 3 books, or 3 music notes. Oh, I shouldn't have said it was going to be easier for me. I think it messed me up. All right, books. So plus 3 music notes equal 25. Well, we can make this easier on ourselves by doing this. B is equal to, I'm going to take away 3M from both sides, is equal to 25 minus 3M. That's what I'm doing right here. So now I have this B is equal to 25 minus 3M. Well, it's a bit of work, but what I'm going to do is I'm going to plug this into my other equation. 3, put a parentheses because we're plugging in. Always put parentheses when you're substituting. Plus 2M is equal to 33. So this is 50 minus 9M plus 2M equals 33. All right, so from here, what we're going to do is we're going to do 50. We have 9 negatives and 2 positives. So 2 of those negatives cancel out, and we're only left with 9 negatives. You get that? And now we want to subtract this 50. Well, let's think of it this way. Let's pretend there's 50 negatives and 30 positives. So we're going to take away 33 positives. So 50, take away 33, make that a 4, carry the 1, 7. So we have 17. So something's wrong here. I did something wrong, guys. I'm so sorry. This was supposed to be a 75. Ugh. It's a good thing I didn't answer these, because any of you guys who fast forward to the answer are probably like, wait, that's wrong. This is more reason for you guys to pay attention instead of just copying the answers. So what I'm going to do here, I'm going to erase all this. And I'm going to do 75 minus 9M plus 2M equals 33. Most of this is going to remain the same. We still have the 73M. The only reason why I knew something was wrong is I was like, I don't think Edmentum is this mean. I don't think they're going to give us a weird fraction. So if I do 75 take away 33, I know it's technically 33 take away 75, but I'm just doing it this way because the math just feels better when you do it. A big number is positive and the little number is negative. So here we get 2 and 4. So we end up getting negative 7m equals negative 42. We're going to divide by negative 7. So if we did that in a calculator, I already know it, but you guys can always use a calculator. We're going to get m is equal to 6. Well, if m equals 6, that's the music notes. M is our music note. So how many music notes? 6. Music note is worth 6. Let me erase this. And then what we're going to do here is now that we have the music notes as 6, we have this as a book plus, obviously I'm going to plug it into this one because this one has less books. A book plus 3 times 6 is equal to 25. Well, that means that book plus 18 equals 25. So that means a book has to equal 7. Because if we take away 18 from both sides, we get 7. All right, so we're going to get 7. Let's see if this works. 7 plus 7 plus 7. So 7 plus 7 plus 7, or in other words, 3 times 7, it's 21. Plus, we said our books was 12 or 6. So we have 6 plus 6, which is 12. That does equal 33. 21 plus 12 does equal 33. I know I skipped a lot of steps, but I see that we're really close to the end here. So I'm just excited for us to be done. All right, so then you can see the steps that they did here. They picked the same way I did it. They're like, hey, all we have to do is move over that 3. Work smarter, not harder. All right, I'm going to move this over here. And let's go over our summary. As always, guys, make sure you're studying this before you take your mastery test. And in this case, before you do your Kahoot on Monday. All right, guys, so those are going to be the videos for this week. I'll see you guys next week. And for those of you in my class, you'll see the Kahoot. Let me sign off.